Welcome back to VRC Smart Edu channel. Subscribe our channel for more videos. So today we are going to see class 10 formula revision series. So already we have made a video of part 1 based on maths formula revision series. There we have discussed formulas for 3 different chapters, right? So today we have uh, came back with part 2 of that, and here we are discussing with 3 different chapters again. Introduction to trigonometry, real numbers and polynomials. These 3 chapters we are going to discuss today. Okay, let us start with discussing about introduction to trigonometry. So, introduction to trigonometry. So trigonometry is always dealing with a right angle triangle. So if you are dealing with a right angle triangle, it is all about the trigonometry. So here we are going to just talk about we are going to talk about okay. So sine theta is equal to opposite by hypotenuse. So what is your opposite direction? AB is your opposite direction and hypotenuse is AC, right? So this is how you read it. Next, what is your cos theta? Cos theta is equal to adjacent by hypotenuse. So what is your adjacent side? BC is your adjacent side and your hypotenuse is AC. Then what is your tan theta? Tan theta is equal to opposite by adjacent side. So what is your opposite side? So your tan theta is equal to opposite by adjacent. What is your opposite by adjacent here? Opposite side is AB and your adjacent side is BC. This tan theta can also be called as sin theta by cos theta. Okay, sin theta by cos theta. And you also have here if you just see means you can able to say that the sine theta is opposite by hypotenuse, cos theta you have, right? So sine theta can be called as 1 by cosec theta. Okay, that is reciprocal of sine theta is your cosec theta. And reciprocal of cos theta is 1 by sec theta. And reciprocal of tan theta is equal to 1 by cot theta. Right? 1 by cot theta. So, if you want to just write for your sin theta or cos theta, you can also write for that. So, just see here how I am going to write for the other values. Okay. So, here we saw till tan theta. So, how to write for cosec theta? As I told earlier, what is your cosec theta? Cosec theta. So cosec theta is inverse of the sin theta. So cosec theta will be equal to hypotenuse by opposite. So what is your hypotenuse? AC is your hypotenuse. By your opposite side is AB. So AC by AB is your formula. Then fifth one is sec theta. Sec theta is reciprocal of what? Reciprocal of cos theta. Then it will be hypotenuse by adjacent, right? Hypotenuse by adjacent, which will be equal to what is hypotenuse? Hypotenuse is AC by adjacent is BC. Then what is your cot theta? Cot theta is reciprocal of tan theta, so it will be adjacent by opposite. So then it will be BC by AB, right? BC by AB. Correct? So, one more thing you have to remember here for 1 mark purpose. For 1 mark purpose, you should remember these things. So, what is the full form of sine theta? Full form of sine, full form of cos, full form of tan. That is really important for the case of 1 mark. So, 1 mark these things can be asked. Okay. So, you have to remember those things also. I'll tell you now. What is the full form for sine? Okay. What is the full form for sine? Full form for sine is I'll write here SINE is the full form for sine, right? What is the full form for cos? Full form for cos is cosine. COSINE. Cosine is a full form for cos. What is the full form for tan? Tan full form is tangent. Full form of tan is tangent. Okay. Then full form of cosec. Full form of cosec is what? Full form of cosec is cosecant. Cosecant. What is full form? So sec theta. So what is the full form you will use for sec theta? So for sec theta, it is secant, right? For sec theta, it is secant. And for cot theta, what is the thing you will use for cot theta? It is cotangent. Okay, cot theta is nothing but cotangent. Okay, so right. Now, I hope you got it. Now let us see the Pythagoras theorem. So what is the Pythagoras theorem states where you can use Pythagoras theorem? Pythagoras theorem can be applicable only to the right angle triangle. So in the right angle triangle, what the Pythagoras theorem is stating? The hypotenuse square is equal to sum of square of the other two sides. That is, it states AC square is equal to AB square plus BC square. Correct? Am I right? Yes. So this is what the Pythagoras theorem states. Now let us move to the very important thing. Here we will be just writing about the angle measurement. Okay. Angle measurement. So these are the standard angles where we will be seeing the values for these angles, degrees. Okay. So sine 0 degree is 0. Sine 30 degree is 1 by 2. Sine 45 degree is 1 by root 2. Sine 60 degree is root 3 by 2. Sine 90 degree is 1. Already we have studied this table in our previous video. There I have teach some important trick to use for easy writing of this table. Okay. So here I am just filling it as it is. Okay. So cos is what? 1 root 3 by 2, 1 by root 2, 1 by 2, 0. And it is going to be 0, 1 by root 3, 1, root 3, infinity. Right? This is what the values that you have to fill there. Okay. Now, we are going to go to complementary angles. So, what are complementary angles? What are complementary angles? So, first, let us take now. So now if I write sine 90 minus theta, this is a complementary angle which will be equal to cos theta. And number 2 I am going to write here is cos 90 minus theta. Cos 90 minus theta is equal to sin theta. Then number 3 is we are going to see is tan 90 minus theta. Tan 90 minus theta is equal to cot theta. Cot 90 minus theta is equal to tan theta. Okay. Then cosec 90 minus theta. Cosec 90 minus theta is equal to sec theta. Then sec 90 minus theta. Sec 90 minus theta is equal to cosec theta. Okay. So this is your complementary angles. These are your complementary angles. Then talking about the trigonometric ratio, very important thing is sin square theta plus cos square theta is equal to 1. This is the very most important formula. You are going to use this formula not only here in your higher classes also you will be using this formula. So really important formula. And number 2, 1 plus tan square theta is equal to sec square theta. Cot square theta plus 1 is equal to cosec square theta. So next we are moving to real numbers. So first, in real numbers, we are going to deal with Euclid's division lemma. Euclid's division lemma. Okay, Euclid's division lemma. Okay, so what is all about Euclid's division lemma? Now tell me, what is all about Euclid's division lemma? Actually, Euclid's division lemma, we have a pair of positive integer. Suppose a comma p is a pair of positive integer, means it is represented as a is equal to bq plus r. It's represented as a is equal to bq plus r, where 0 is less than equal to r is less than b. Right? So let us have an example. Let us look at a small example. So our example is 455, 42. This example we are going to solve now. Now what I am going to do is, I am going to consider now, initially this as my A and this as my B. I am going to divide 455 by 42. While I am dividing, so I should write in this format. So 455 is equal to 42. Q is nothing but the quotient that you are getting. Okay. Into what you just divide. For example, if I divide the 455, if I divide, I am going to divide it by 42. How many times I am going to do means, I am going to do 10 times. So 4 to 0 I will get. So when I subtract, I am going to get 35. When I am going to subtract, I am going to get 35 as my remainder. So that I am going to write 10 plus 32. Now what you have to consider, till you are getting 0 at this place, you have to perform the function. Till you are getting your remainder as 0, you have to just perform. Here you have to get 0. Okay. So next you have to consider this as your A, and next you have to consider this as your B, and you have to start doing it. So 42 is equal to 32 into, what you multiply, 32 into 1 I am multiplying, plus 7. So again I do not get my remainder 0. So again I am going to consider this as A, again I am going to consider this as B. So what I am going to do, 32 is equal to, what I will get, 7 into 5 plus, oh, okay, wait, 35, right? 35. So this is 35. Yes. So this is 35, this is 35, this is 35. So 7 5s are 35 plus 0 you will get. Right? So now if you see, means you are getting 0 here. Then this term will be your HCF. Okay? This term will be your HCF. This is how you will find the HCF. So here your HCF is equal to 7. So this is how you will find the HCF by Euclid's division lemma. Clear? Okay. And one more formula here I am going to give you, very important formula again. If, for example, your LCM or HCF, any one thing is given. So LCM of AB or HCF of AB, any one thing is given, and your A and B is given, you can find the value. So relation between that, LCM into HCF of A, B will be equal to A into B. This is the one more formula, important formula you can remember. Right? One more formula. That is a relationship. Okay? Right. So now we are going to see about the irrational numbers. We are going to see about the irrational numbers. Irrational numbers. So what are irrational numbers? Example, if you want to give, means root 2, root 3, root 5, root 7. These are some of the examples of irrational numbers. Right? So when any irrational number is added or subtracted with any whole number or irrational number, what you will get? When any irrational number is added or subtracted, you will get an irrational number. You will get an irrational number. Okay? Okay. Then next point is, if P is a prime number, if P is a prime number, P is a prime number, and this P is dividing the P divides A square. If P is dividing A square, then P will also divide A. Then P divides A also. Okay? P also divides A. If let your x is equal to P by Q. Okay. So, if you do the prime factorization of Q, on prime factorizing Q, okay, prime factorization of Q is of form 2n 5m, where your n and m are positive integer. Okay, n and m are positive integer. Then x is having terminating decimal expansion. Terminating decimal expansion. Okay. So if same, you are going to consider P by Q, prime factorization of P by Q, we are going to say, we are going to consider x is equal to P by Q, the prime factorization of Q is not equal to 2n 5m, where n and m are positive integer. Then what can we say? Then the given x is non-terminating. Recurring, non-terminating repeating. Okay. So now we are seeing about the polynomials. So first initially we are going to deal with the degrees of polynomial. So degrees of polynomial. So degrees of polynomial. So in degrees of polynomial we have, first one is, for example, if I am going to have x plus 1. So degrees of polynomial means highest power is called as degrees of polynomial. So here highest power is 1. So here the degrees of polynomial is linear. Here the degrees of polynomial is linear. Okay. So here your x is not equal to 0. Okay, x is not equal to 0. And another case I am going to give is x square plus 2x plus 3. Here what is your highest power? 2. So it is a quadratic. So here your x square is not equal to 0. Always your first term will not be equal to 0. Then this equation will become linear, right? So it will not be the quadratic. So only. Next your 2x to the power of 3 plus 8x to the power of 2 plus 2x plus 1. What is this? This is cubic, right? This is cubic. Here also your x cube is not equal to 0. So now till cube, if you know, that is enough. Okay, till cube, that is enough. What is degrees of polynomial? We are just seeing the highest power. We are just seeing the highest power. Clear? Till cubic it's enough. Now, how to determine these zeros using the graph? Just I am drawing an example. See, if this is your graph. Something like this. This is your graph. This is a graph. Tell me how many zeros are there here. and B graph I am drawing. So this is your B graph. Tell me how many zeros are there in B graph. How do you determine the zeros in graph? You are just going to see how many times your line is touching the x-axis. This is your x-axis and this is your y-axis. We know it already. So you have to just say me how many times it is touching the x-axis. If you just see in this case, first case, it is touching the x-axis 2 times. So that number of zeros is 2 here. The number of zeros in this case is 2 here. How many times it is touching? 1, 2, 3 times it is touching. So number of zeros is 3 here. Clear? 3. So now the next one is, so in general, what are the zeros for quadratic equation? In general, alpha and beta are the zeros of the polynomial. Zeros of the polynomial for quadratic equation. So your px is equal to ax square plus bx plus c is equal to 0. This is the general form. Okay, see. Okay, this is the general form of quadratic equation where your a is not equal to 0, right? Okay, this is your general equation, general form of equation. Now what I am going to do means I am going to just show the factors. What are the factors of this? Factors are x minus alpha and x minus beta are the factors. Then how can we solve this? Ax square plus bx plus c is equal to, we can write k into x minus alpha into x minus beta. So if you multiply the k, what happens? K, you just expand this. Okay, this is x minus a into x minus b. With that will be x square minus a plus b into x plus ab, right? So that formula we are using here. So if you expand, you will get kx square minus k alpha plus beta into x plus k alpha beta. This one you will get. So if they have asked you to find the equation, you can use this. You can use this and find the equation of the polynomial. If they have given the zeros of the polynomial, ask you to find the equation, you can use this. Okay, you can use this and find. You can use this and find. Okay, so now what are the sum of zeros and products of zeros we will see. Okay, so what are the sum of zeros? Sum of zeros is equal to alpha plus beta, which is equal to minus b by a. Product of zeros is equal to alpha beta, which is equal to c by a. Okay, c by a. Now we saw for quadratic equation. If it is a cubic equation, okay, if it is a cubic equation, then what you will do? Okay, if it is a cubic polynomial, then what you will do? It will have 3 zeros. It will have 3 zeros. What are the zeros? Alpha, beta and gamma is introduced here. So 3 zeros you are having. Alpha, beta and gamma. So what are the sum of zeros here? Sum of zeros is alpha plus beta plus gamma is the sum of the zeros, which is equal to minus b by a, which is equal to minus b by a. Then alpha beta plus beta gamma plus alpha gamma is equal to c by a. Then this is the sum of product of zeros. Then product of zeros is alpha beta gamma, which is equal to minus d by a. Clear? So this is first one, this is second one and this is third one. Right? Okay. So then we will be having the final formula is, usually we say dividend. Dividend is equal to, so dividend. So dividend is equal to, dividend dividend is equal to divisor into quotient plus remainder. So now your dividend is nothing but P of x is equal to G of x into Q of x plus R of x. So here your R can be equal to 0, or your R should be R of x, it is the degree of R of x. Okay, degree of R of x should be less than the degree of G of x. Clear? Keep this in mind. Okay. So that's all. So thank you for watching. Thank you so much for watching this video, and I'll be coming up with future videos with future lessons also. And kindly subscribe to our channel for more updates. Thank you.